questions at all, so I'm gonna move forward then to exponential. This is a little early, you sure? Maybe we should just go right into lambda. Right into lambda. Lambda will be your favorite word for the rest of the semester. Hey lambda. See, it's my favorite word, I can't help myself. All right. How can I show you lambda? I gotta think about this. Okay, how about if I go straight to an example? Exponential, 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 exponential. What I want to say about exponential is that you determine what kind of problem you have in front of you based on the question of what you have to find the probability of. Let me say that again. Do not base what kind of question you have when you read the mean, the average. You read the mean and average, don't let it sway you either way, whether it's a Poisson or exponential, because both of them state the mean or average different ways. So don't let that, or the same way even most of the time. Instead, focus on the question of what you're being asked to find the probability of to determine whether you're looking at exponential or Poisson. So for example, if you're being asked to find the probability of some time between vehicles arriving at a booth, because you're being asked the probability about an interval, what's the probability there'll be 2 minutes between the next two vehicles coming to this booth? Notice the question was, what's the probability of the time of 2 minutes? Because the question was asking you the probability of an interval, that's how you know it's exponential. Now I'm going to use this toll booth, and I'm now going to just hypothetically throw a question out there that's Poisson on purpose. So you can see it's almost just like exponential, but this is now Poisson. You ready? What's the probability there'll be 5 cars in the next 10 minutes at my toll booth? I'm asking you for the probability of the number of cars coming to the toll booth. That's called the events. That's Poisson over an interval, 5 minutes or 10 minutes or whatever I said. But this question I just read, what's the probability there'll be 5 minutes between the next 2 cars in my toll booth? That's asking you about the time, the interval between the events. That's how you recognize it's exponential. All right, let's do the next one. Time required to complete a questionnaire. What's the probability there'll be 5 questionnaires completed in the next half hour? Poisson or exponential? Poisson, because I asked about the number of questionnaires finishing over an interval of the half hour. But this question would be, what's the probability that it will be a half hour between the next 2 questionnaires handed in? I'm asking you the probability of the time between those events of the questionnaire being finished. That's how you know it's exponential. I know, it's all about you saying, okay, is this asking about the probability of an interval, or is it asking about the probability of some event during an interval? That's what makes it hard. Here it is. Exponential could be about the distance between major defects on a highway. Here we go. What's the probability there'll be a mile between the next 2 defects? Exponential or Poisson? I couldn't hear you guys, but hang on. Let me get it out of the way of the fan. Let me repeat it real quick because I couldn't hear you. What's the probability there'll be a mile between the next 2 defects on this highway? Is that exponential or Poisson?
Exponential.
I hear Poisson, I hear exponential, I hear 2 answers. Because the question said, what's the probability there'll be a mile between the events of a defect? That's an interval I'm asking about. That's why it's exponential. Because it was asking the probability of that mile, the interval between the events of finding a defect. But if I would have said, what's the probability there'll be 2 defects in the next mile of this highway? Now I'm asking the probability of the defects themselves over an interval of a mile. That's Poisson. I want to tell you, this is the hardest thing. When I was in stats, I could not tell the difference between Poisson and exponential. I never had anybody explain to me what to focus on. And I kept accidentally basing it on how the mean was being described instead of the question. So this is why I'm really hyping on this, because once you figure it out, how to find the difference between exponential and Poisson is not that hard. It's just hard to get the grasp on exactly what it is. So now, here's your first, by the way, slide 36. Write yourself a note. Do not use slide 36 formula. No matter what you think you're using the right formula, do not use this formula. This is not ever going to be asked about. And I know there's going to be someone that uses it because I haven't been able to have a class where somebody doesn't use it yet. So don't use it. Maybe I should just take the slide out of the PowerPoint. It's too late now, but I guess that's what I should do. This is going to be your formula, but ignore it because that's Thursday. Here, we're going to talk about it now, and I'm going to explain why this is exponential. Are you ready? A1 full service pump. Now I know you guys probably don't know what a full service pump is because you were born after full service pumps disappeared. But when I was a punk like you, back in the old days, I could drive to a gas station and stay in the car. And someone comes running out of the building and they ask, what would you like? And you say, fill it up, or you say $5 worth, or whatever you said. And then they would take the thing, handle off the pump and put it in the side of your car. And then they would start washing your windshield. They start washing your headlights, your tail lights, and wiping down a few other things, especially if you're filling up. And if you're filling up, they bring you out like a free souvenir plate or 4 little glasses or something. That's what it used to be like. I know it's shocking, isn't it? Ask your parents. It's crazy. So this is a full service station. And this is all about the cars and how often they come pulling up. They aren't even getting out of the car. They pull up, they assert, they drive back on. And it says the time between arrivals of cars at the A1 full service gas pump follows an exponential probability. I'm not going to say those words, follows an exponential probability. That's for you to figure out what kind of questions being asked. With a mean time between arrivals of cars of 3 minutes. So there you go. There's the mean. 3 minutes. Doesn't mean you're going to use 3 in this problem. Matter of fact, it will be very rare that the mean being described to you is what you're using in the problem. This is what Lambda is all about, is you got to figure out how to convert that mean to something you can use in this problem, and in the manual problem also. So it says, the mean time between cars pulling up to the full service pump is 3 minutes. A1 would like to know, what's the probability the time between 2 cars arriving is 2 minutes or less? Now, this is where you go, this is exponential. It's asking about 2 minutes between cars arriving. Cars arriving is the event, it's asking about the interval, it's exponential. Now, it's asking about 2 minutes. You don't ever change that. That's asking about 2 minutes. Look at, where's my x? I just found x. I know there's a 1 on the end. All I'm missing now is lambda on this problem. Okay, hang on, let me get right in front of this camera. Ready? Lambda is the number of events in 1 unit of the interval being asked for in the question. I know I gotta repeat that. I tried to go slow. You ready? And you're gonna be able to play it back. Lambda is the number of events in 1 unit of the interval being asked about in the question. Lambda is the number of events, the average number of events that would take place in 1 unit of the interval being asked for in the question. Okay. I'll try to repeat that a couple of times before we leave today, or I'll definitely repeat that on Thursday if anybody's feeling like they're just not quite getting this. Are you ready? So what's being asked for in the question? Not how the mean's being described. Let's ignore the mean for a second and just look at the question. The question says, and I'm right here in this last sentence, A1 would like to know the probability that the time between successive arrivals is 2 minutes or less. The question's about minutes. It says 2 minutes or less. That's the interval in the question. So lambda has to be, now that we know the question's about minutes, lambda has to be the number of average events in 1 unit of the question, which is minutes. So now lambda is the mean number of events in 1 minute. Because lambda is however many average number of events in 1 unit of the interval being asked for. The interval being asked for is 2 minutes. So minute is the interval, and we need to know on average how many cars pull up to that pump in 1 of them. 1 minute. So let's think about it now. here's the gas pump, all right, whatever. And I'm gonna put one of those old-fashioned light-up bulbs on top. It reminds me of, forget it. Anyway, this gas pump, ready? Cars are pulling up. Let's say 60 minutes go by, 60 minutes. We got a car pulling up, another car pulling up, another car pulling up. 60 minutes go by. It says right there on average, there's 3 minutes between every car. So if we have a car pull up here, this one pulled up in the first 3 minutes. This one pulled up in the second 3 minutes. This one pulled up in the third 3 minutes. This one in the fourth 3 minutes. How many minutes have we got? 1, 2, 3, 4 times 3. That's 12 minutes right there. 12 minutes. Let's go to 15 minutes. Now how many cars we got? 5 of them. Let's go to 18 minutes. 6 of them. And we could go on and on and on. But the point is, you have to figure out how many cars will pull up to a pump in 1 minute, because that's Lambda, and that's what goes in the center. And that's what you're going to be using on Thursday when we do these manually. How many cars pull up to the pump in 1 minute? How long does it take for one car to pull up? How long does it take? 3 minutes. It takes 3 minutes for one car to pull up, so how do we figure out how many cars are pulling up in 1 minute? There's only a third of a car that can pull up in 1 minute, because it takes 3 minutes for a full car to pull up. If it takes 3 minutes for a full car to pull up, that means a third of the car, a third of the car, a third of the car. So the number of cars that can pull up to this pump in 1 unit of the interval being asked for in the question, which is minutes, is 1/3. That's Lambda. Wow, we went through all that to find Lambda, but that's what you got to go through. Because Lambda isn't so easy as we just saw just now. It gets harder and harder. You're going to see the most common one is that when you're given the mean in an amount of time for the first event, that means 1 over that amount of time is usually the amount of events in 1 unit of that time. Usually, they're not all this way. So I barely wanted to even point that out to you, how easy that was to get to 1/3 when it's telling you 1 in 3 minutes, how many in 1 minute, because they're not all that way. But that more than 50% of them are that way. So if you're saying, I can't figure this one out, just try 1 over whatever number the mean is. Maybe your Lambda possibly, but don't count on that. All right, let me try another one. Hang on. I got another one here. We're going to slide 38. Excuse me, we're already on 38. We're going to page 222. Okay, at the bottom of the page, here we go. Here we go. Nope, it didn't go. Hang on. Excuse me. Okay, let's see. All right, I'm going to try to read this. I can barely see it. It says, right down here at the bottom of the page, right here. It says, let the time between email messages during work hours be exponentially distributed with a mean of 25 minutes. Let me put that in words you might see on a quiz. It says, the time between email messages during working hours has a mean of 25 minutes. All right, now let's see what the question is. We're going to C, go all the way down to C. What's the probability that you get an email within 10 minutes? So they're saying 10 minutes between emails. Like we just got one, it's done. Now what's the probability to be 10 minutes before we get our next email? Notice, what's X? Right now, what is X in this, what we just read here? What is X? 10. It's asking about 10 minutes. There it is. You never have to change that. There it is, it's asking about 10 minutes. Now here we go. We gotta look at the mean, and then we gotta say, Lambda is how many, what's the event? What's the event we're counting in this 10 minutes? What's the event? Email. An email showing up at your work email. That's the event. So now we're trying to figure out how many emails would show up in 1 unit of the interval being asked for in the question, which happens to be 10 minutes. So we need to know how many emails on average in 1 minute. How long does it take to get one email? 25 minutes. If it takes 25 minutes to get an email, how many emails do we get in 1 minute?
Is it 1 minute or 10 minutes?
No, we got to do it in 1 minute. The question's about 10 minutes, but lambda is how many on average in 1 unit. Always. Let me repeat that about lambda. Lambda is the number on average for 1 unit of whatever the question is. If that question was about hours, it's how many on average in 1 hour. This question is about days, it's how many on average per 1 day. This question is about weeks, it's how many on average per 1 week. So because this question is about 10 minutes, it's how many do we receive on average in 1 minute. But it takes 25 minutes to get the first one. So this is one of those problems where you go, oh, I get 1/25 of an email in that first minute. And then a second 25th, and then a third 20th. And when I get to 25 minutes, I got the email. So on average, I only get like 1/25 of an email in 1 minute. That's lambda. We can find the probability now of getting an email within 10 minutes. But by the way, is that 10 minutes or more or 10 minutes or less? Within 10 minutes?
Less.
10 minutes or less. And so we now have the exponential distribution equation to solve that for 10 minutes or less. There's the 1 on the end for exponential, always will be, and 1/25. What if this said, what's the probability it will be 10 minutes or more before our next email? What changes on this equation? That's right, 1 minus in front. And what about here, anything? No, this isn't Poisson, this isn't binomial. If this were Poisson or binomial, we gotta use the opposite of 10 minutes or more, which would be a 9, but this isn't, this is exponential. Normal and exponential, you never change that first number in the parentheses. It's whatever's being asked for. In this case, 10 minutes or more. So we put a 10 for the first number. You get it? You guys got to have that rule down. Binomial and Poisson in the parentheses for a more than is the opposite of what's being asked. So then you got to do some thinking. But with normal and exponential, whatever's being asked for, whether it's more than or less than, you use that number that's being asked for. You don't have to change it. All right. Okay, I got another one. I want to make sure you're getting this. Let's see, I'm going to page 227. I'm going all the way down near the bottom, number 64, right down here. Hang on a minute. Right there, right there. Says studies have shown that bats can consume an average of 10 mosquitoes per minute. That's good news. Assume that blah, 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 consumes per minute, assume that the number of mosquitoes consumed per minute follow a Poisson. Poisson? What is this? Poisson? Did I really put that one on there? No, it doesn't matter. Let's keep going. Yeah, let me see. Okay, here we go. Ready? B says, find the probability that the time between eating mosquitoes is more than 15 seconds. At the time, now notice, it's not asking you to find the probability of the bats eating 5 mosquitoes in the next 2 seconds. It's asking you the probability of the amount of time between eating mosquitoes, which I just forgot the amount of time, 15 seconds. Find the probability that the time between eating mosquitoes is more than 15 seconds. Here we go. Help me out here. Help me out. What's X? 15. Whoop. Do I get rid of this 1 minus in front?
No.
Why?
That says more than.
Because it says more than. I got the 1 minus in front because it says more than 15 seconds. It's asking about 15 seconds. What about the end here? What number goes on the end?
1.
1, always. That one's easy. Now it's lambda. Here we go. The mean was given to us differently. It wasn't given to us as an interval. It was given to us as a number of events during an interval. We have to convert however the mean's ever being described in any way whatsoever to lambda. The number of events per one interval, 1 unit of the interval being asked for in the question. And the question's in seconds. So we got to figure out the average amount of mosquitoes eaten in 1 second. 1 second. Let's see how it was described to us. Let's see, the mean was described as this. I gotta read it again. Studies have shown that bats can consume an average of 10 mosquitoes per minute. Let me get this right here. 10 per, how many seconds in a minute? 60. But we need to know how many per 1 second. Look what I just did. I set up this as a ratio where we can cross multiply and divide and easily get this number. If the average is 10 per 60 seconds, and lambda has to be per 1 second, 1 times 10 divided by 60. 1 times 10 divided by 60. I don't have it off the top of my head. Is that 0.6? What did I say? 1 times 10. Is that right? 10 divided by 60. Did I make a mistake? Did I make a mistake? Okay, that totally sounded like I made a mistake. Was it a mistake on my head? Okay. Point, here we go. This is point, oh, you don't have it up on the board. Darn. It says, what did anyone else get? Tell me what you got. Point what? What was 10 divided by 60? 1 times 10 divided by 60. 0.1. Thank you, 66666. That's lambda. Or I could have made it a fraction, but I'm going to put it as 0.166666667. However far I want to put it, and then I'll end with a 7 because I'll round up wherever it is I round. Look at what we had to do to find lambda though. Let me repeat this. The question described the mean in like this was a Poisson question. It said bats eat an average of 10 mosquitoes per minute. It didn't even give us the mean as to the amount of time between eating mosquitoes on average. This is one of those where, hey, this looked like a Poisson question. But then we got to the true question, and it asked the probability of 15 seconds between eating mosquitoes. Now you go, oh, this has to be exponential because it's asking the probability of this interval of 15 seconds, so it doesn't make sense to be Poisson. But yet the mean was being described as Poisson. We had to convert it to lambda. However that mean is described, whether it's being described as an interval or the number of events over an interval, however the mean is described with exponential, you've got to convert it to lambda, which is however many events in 1 unit of the interval being asked for in the question. This question was about 15 seconds, so we had to find lambda per 1 second. Everybody get that? I really typed it in pretty good, I thought. I mean, I'm sure everyone will forget it, because I did, but. Do I have one more? I think I have one more if you want one more. I'm going to page 228, number 70. This will be our last one. Thought I heard applause. Okay. So, see if I can zoom this in. Oh, wrong way. Come on. Okay, 70 says, where am I? Right here? On average, the state police catch 8 speeders per hour. Here we go. 8 per 1 hour, which would be 60 minutes, which would be whatever, something amount of seconds, 60 times, let's see, 60 minutes, there's 60 seconds in a minute, 60 times 60, that's 3,600 seconds, or what is that? Whatever. I'm just putting it right there. 8 per hour was the description of the mean. But we don't know what the question is yet. So let's get to that. The question says, what's the probability that the state police wait less than 10 minutes for the next speeder? Wait less than 10 minutes. Okay, here we go. What's X? Do I need the 1 minus?
No.
Because it's wait less than 10 minutes or less, so we get rid of the 1 minus. What's X? 10. What's the last number? 1. Now lambda. This is it. This is the only hard part about this. Once you recognize it's exponential, you know what X is, you know the last number is going to be a 1. You'll learn how to do this manually on Thursday. But right now it's all about using Excel to solve it for your homework. And lambda is going to be however the mean is being described. And the mean is being described as 8 speeders per hour. 8 per hour. But it's actually for the probability of the next speeder in 10 minutes or less. Lambda will be in what interval? Yes, minutes. So who said? Someone say it? And not just minutes, 1 minute. Lambda is about how many per 1 minute, because lambda is always about how many per 1 unit of whatever the interval is being asked in the question, and the question's about 10 minutes. So lambda has to be how many per 1 minute. So I gotta convert 8 per hour, which is 60 minutes, equals something per 1 minute. 8 per 60 minutes, I converted that to minutes because I gotta get 1 minute. 1 times 8 divided by 60 gets you your x, your lambda, right? How many per 1 minute? Because we were told it's 8 per 60 minutes, 8 per hour. 8 divided by 60, let me get this again, I got 8. Someone make sure you confirm what I get is true. 8 divided by 60, 0.13333, anybody else? Destiny? Thank you. 0.13333 is my lambda. Because I converted the 8 per hour to 8 per 60 minutes because I had to get to 1 minute. Is how many in 1 minute? 1 times 8 divided by 60. Lambda is 0.133333, however many you want to put there, and then round to 3. That's it. Boy, this class is easy. How can this class be so easy? I thought we were all supposed to flunk.
So can you cross multiply always with this?
You can.
Okay.
You can. Sometimes you don't have to because it's
Right.
like at 125, what was it? Takes 25 minutes. We get 1 every 25 minutes equals how many in 1 minute? 1 times 1 divided by 25. There you go, I guess. That's your lambda. You actually have lambda right there. Some are easy to determine what lambda is. Some are a little harder. And it's just a matter of if you get in the right frame of mind, saying, number 1, don't allow however the means described to determine whether you're looking at a Poisson or exponential. Always go to the probability part of the question to determine whether it's Poisson or exponential. Then go back and adjust the mean based on whether you're doing a Poisson or exponential. All right. Those who walked in late, come and get your in-class assignments. And anybody who hasn't signed in, please sign in. And we'll pick up from here on Thursday. Last one,